Hello, chemical bonding and molecular structure for all board examinations of class 11, all boards, okay, intermediate public examination, CBSE boards, whatever it is. Long answer question choice is from chemical bonding, and that question chances are in general hybridization from this chapter. Hybridization or molecular orbital theory or hydrogen bonding dipole moment, ionic bonding. We'll see the possible long answer questions from this chapter. Maximum possibilities. You follow these notes, you will be getting 100% marks. Damn sure. Okay, so let's discuss this. I am going to explain here the question answer. That means if you follow this video, you will be able to understand and you will know what to write, because in examination writing is also important. Which points are to be incorporated, okay, in your answer. That is the point we are discussing here. Sometimes students get confusion, in this much big answer is there, how many points we need to write. So this video will be helpful for all those students who are weak, who think that they are weak in chemistry, and who think that they are moderate. For all those, as well as if you are a super good student also, then you should know what to be written. Okay, otherwise if you are writing many things in one answer, and you won't get sufficient time to answer the next one. So editing is also a very important job, right? So let's discuss chemical bonding and molecular structure questions. First one, what do you understand by hybridization? Explain different types of hybridization involving s and p orbitals. S and p orbitals letters must be always small letters. The intermixing of atomic orbitals to form new same number of equivalent orbitals is called hybridization. Okay, intermixing of atomic orbitals to form new same number of equivalent orbitals is called hybridization. Like you are mixing 3 4 different colors and you are getting a new color. Okay, now that color is not available even in the market. Take green 1 liter, blue 1 liter, orange 1 liter, all these you add. Okay, now that color may not be available in the market, okay, with a particular name. That's hybridization. You are getting same number and same type of orbitals. Types of hybridization. sp hybridization, intermixing of one s orbital and one p orbital to give two sp hybrid orbitals is called sp hybridization. Shape is linear and bond angle is 180 degrees, means one orbital like this, second orbital is like this, between them the angle is going to be 180 degrees. S character is 50% and P character is 50%. Formation of BeCl2 is the best example. You have to show like this. In BeCl2, beryllium atom undergoes sp hybridization. The shape of the molecule is linear shape. Angle between them is 180 degrees. Beryllium chloride. There is no need to show all this nonsense, but if you want, you can see this. These are sp hybridized orbitals of beryllium. Now to this, one chlorine will be adding from this side, another chlorine coming from this side. All this is not required. Without writing this also, you will be getting complete marks. 100% marks you are going to get, don't worry, right? So this is enough. sp hybridization, linear shape, bond angle. If you mention these points, that's enough. These two are chlorine atoms, p orbitals of chlorine atoms. So what is the overlapping? Sigma sp of beryllium chlorine's p orbital. If you want to add extra masala, you can add this, right? Coming to the second one, sp2 hybridization. Now you can write the remaining lines as it is of sp. Intermixing of one s orbital and two p orbitals to give sp2. Three sp2 hybrid orbitals is called sp2 hybridization. Shape is trigonal planar and angle is 120 degrees. S character is 33.3%. P character is 66.6%. And formation of BCl3 is the best example. 120 degrees is the angle. Sorry, sp2 hybridization, trigonal planar, and 120 degrees. If you want the overlapping is sigma sp2 orbitals of boron, p orbitals of chlorine. Okay, now this is called nature of overlapping, or you say overlapping. Coming to sp3 hybridization, intermixing of one s orbital and three p orbitals to give four sp3 hybrid orbitals is called sp3 hybridization. Shape is tetrahedral. Bond angle is 109 degrees 28 minutes. S character is 25%, P character is 75%. Formation of methane. Okay, now this distance is not required, don't worry. If you are writing, that's a very good thing. And this is 109.5 degrees. Okay. In organic chemistry, we write many number of times. Otherwise, you can simply write like this: 1, 2, 3, 4. Add these lines. Draw dotted lines between all these bonds. This is only called tetrahedral. Nature of overlapping is sigma sp3, hydrogen's s orbital. Fine. So this is one of the very important long answers. Give an account of VSEPR theory and its applications. VSEPR, valence shell electron pair repulsion theory, was proposed by Sidgwick and Powell. Later it was developed by Nyholm and Gillespie. Postulates. The shape of the molecule depends upon the number of electron pairs in valence shell of central atom. The shape of molecule also depends on electron pairs. Electron pairs means lone pair of electrons. The bond angle of the molecule depends upon repulsion between the electron pairs and electronegativity difference between the central atom and bonding atom. A lone pair of electron occupies more space around the central atom than the bond pair of electrons. The repulsion order is lone pair repulsions are greater than lone pair bond pair than bond pair bond pair. Repulsions among triple double single bonds in the order of triple greater than double than single. If you write these 2 points and you need to underline these points. Simple. Shape of the molecule is decided by number of lone pairs, number of bond pairs, number of electron pairs. Okay. If number of electron pairs are, you see, here 2 bond pairs, 0 lone pairs, example is BeCl2 linear. 3 bond pairs, AB3 type, BCl3 trigonal planar. 4 bond pairs, tetrahedral. 5 bond pairs, trigonal bipyramidal. 6 bond pairs, octahedral. 7 bond pairs also you can add. Okay, now 7 bond pairs if you want to write AB7. IF7 is the example. 7 bond pairs, 0 lone pairs, that is pentagonal bipyramidal. If you want to add this one, you can add this also. Right. Now coming to the lone pair cases. Water, if you take, water contains 2 bond pairs and 2 lone pairs. In this case, the molecule is angular. Total electron pairs are 4. So you expect tetrahedral, but it is angular due to lone pairs. Similarly, ammonia 3 and 1, it is pyramidal. General question is, they ask you to explain ammonia molecule. In ammonia, nitrogen is sp3 hybridization. Nitrogen, you say, undergoes. Nitrogen atom undergoes sp3 hybridization. Shape is tetrahedral and bond angle is 109 degrees 28 minutes. The central atom in ammonia molecule is N. It contains 1 lone pair, 3 bond pair of electrons. According to VSEPR theory, bond angle decreases to 107 degrees and shape changes to pyramidal because of the lone pair. Due to lone pair. Similarly, structure of water molecule. In water, oxygen hybridization is sp3. So shape is tetrahedral and bond angle is 109 degrees 28 minutes. The central atom in water is oxygen. It contains 2 lone pairs and 2 bond pairs of electrons. According to VSEPR theory, bond angle decreases to 104.5 degrees and shape changes to angular. Actually, when you are writing the answer VSEPR theory based, you should not mention hybridization. But everything is fair. Okay, now you can comfortably write, no problem, because whether the data is there or not, they will check. But ammonia and water molecules question can be asked. Ammonia 1 lone pair, water 2 lone pairs, here 3 bond pairs and here 2 bond pairs. This is pyramidal and this is V shape. Correct. Coming to the molecular orbital energy diagram of nitrogen and oxygen, calculate the respective bond order, write the magnetic nature of N2O2 molecules. Very, 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 very important. See here how it is going to be. Nitrogen atomic number is 7. Electronic configuration is 1s2, 2s2, 2p3. That you are writing here. 1s2, 2s2, 2p3. Similarly, it is again 1s2, 2s2, 2p3. That means this is one nitrogen atom. This is another nitrogen atom. These are called AO. AO means atomic orbitals. Then these middle row is called molecular orbitals. Okay, now if you want to keep some clear difference, you can show like this. Atomic orbitals and molecular orbitals. See, when sigma 1s join, they form sigma, 1s orbital, when they join, they form sigma 1s and sigma star 1s. 2s orbitals will give you sigma 2s and sigma star 2s. This you can see here. And then 2p orbitals, when they join, they are going to form 6 orbitals, which are pi 2px, pi 2py, sigma 2pz, pi star, sigma star. The down orbital is called this, for example. This orbital is called a bonding molecular orbital, which gives stability, and this is called anti-bonding molecular orbital. Just for idea. All these are not required here. You can directly show like this. So total how many electrons? Each nitrogen 7. So total 14 electrons are there. Fill them 14. 2 here. 4, 6, 8, 10, 12, 14. 14 over na? So number of bonding electrons. Bonding electrons means don't see the star. This one. 2, 4, 6, 8, 10. Minus anti-bonding. This one and this one. 4 by 2. Bond order is equal to number of bonding electrons minus number of anti-bonding electrons by 2. That is nothing but 3. 3 means nitrogen contains a triple bond. And there are no unpaired electrons, so it is diamagnetic. No unpaired electrons is diamagnetic. Clear? And now the oxygen. Oxygen is little special because the order is slight change in order is there. sp mixing is not possible here, so slight change in order will be there. First sigma 1s, sigma star 1s, sigma 2s, sigma star 2s is same. Then here sigma 2p comes first. Sigma 2p is here, but sigma 2p comes first, then pi 2p, rest is same. Sigma 2s position is slightly different, just notice that point. Oxygen, each oxygen contains 8 electrons, 2, 3, 4, 5, 6, 7, 8. Here also same, this is oxygen's atomic orbital, oxygen's atomic orbital. The middle row is molecular orbitals. 4 electrons are here, 4 done. 4 electrons are here, 4 done. Here 4 and here 4, 8 electrons are there, 2, 2, 2. These are equal energy orbitals, so 1 by 1 you need to fill. Correct? So that we are writing here sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px1, pi star 2py1. This is 1 and 1, you notice. Because of this is paramagnetic in nature due to unpaired electrons. And bond order, number of bonding electrons 10, anti-bonding electrons 6 by 2, that is 2. Bonding, and these are all bonding. Antibonding, antibonding, and these two are antibonding. Fine. Question number 4, explain the factors favorable for the formation of ionic compounds. Okay. No jar time again. Okay, take a break. No problem. Play button, pause it for some time. You have learned 3 long answers, very, very important job. Explain the factors favorable for the formation of ionic compounds, right? Ionic bond, the strong electrostatic force of attraction between oppositely charged ions is known as ionic bond. It takes place due to transfer of valence electrons from one atom to another atom. NaCl, MgCl2, Mgo are the examples. Formation of NaCl, if you want to see, it is formed by the strong electrostatic forces between sodium plus and Cl minus ions. Okay, how sodium plus is formed? Formation of Na plus ion. Sodium belongs to first A group, so it loses one electron and readily forms sodium plus ion. By losing one electron, sodium attains electronic configuration of noble gas. Octet configuration is obtained. Right? So we are discussing favorable conditions for the formation of ionic compounds. All these must be small letters. Formation of Cl minus ion. Chlorine belongs to 7th A group, so it gains one electron, readily forms Cl minus ion. By gaining one electron, chlorine attains octet configuration in valence shell. So here is right. Chloride ion. Now between Na plus and Cl minus, NaCl is formed. And favorable conditions for the formation of ionic bond. The formation of ionic bond is influenced by nature of cation and nature of anion. Nature of cation, nature of anion. Okay. Cation purpose, size should be large. Large cation favors formation of ionic bond because when the size is large, it can lose the electron easily as the ionization potential value will be less. For anions, size of atom must be small. Small anion favors formation of ionic bond because when the size is small, they can accept the electron pair, the electrons easily because their electronegativity and electron gain enthalpy will be more. Charge on the ion, less charge is favorable for the cation formation because when the charge is small, electrons can be easily lost because of less nucleus power. Interestingly, for anions also, less charge is only favorable because when small charge is there, less charge is there, it can accept electrons easily and there are less repulsions among the electron pairs. Ionization potential, atoms with low IP values, they can form cations very easily. Atoms with high electronegativity and high electron affinity form anion easily. These points if you are going to mention, that is enough. These 4 questions. Okay, now VSEPR theory, hybridization, and ionic bond formation, molecular orbital theory. Question definitely will come from these 4 only, 100%. Okay, and other hybridization can be asked that we will discuss under the category of short answer type questions. I will upload soon. So this is video lecture 1 for chemical bond. Thank you.